So many organizations have spent years and lots of money trying to perfect their external network defenses. And as more and more of them are moving to the cloud, you may have heard the term identity is the new perimeter. And this is the case. A lot of the times getting the keys to the kingdom is as simple as a permissions misconfiguration rather than performing some crazy next level zero-day attack. So in this video, I'm going to break down in different steps how we can go about attacking Microsoft Entra ID, as that's one of the most popular identity management systems in the cloud, and what you can learn about an organization if you had a scope document with just a domain name come across your desk. I'm probably going to split this up into different videos for once you actually get a foothold into their environment, but for this one, we're just going to find out what you can do from the outside. One of the most important things to check before you test any cloud platform is the rules of engagement for that specific platform. A client can give you permissions to test, but unless they align with the cloud platform's rules of testing, then you could be held liable for anything that you do wrong. Here is the Microsoft Azure rules of engagement. And the most important section here is the prohibited activities. So most of these are pretty common sense, accessing customer or Microsoft data that you don't have permission to test or access, denial of service testing, network intensive fuzzing, and distributed denial of service and all those things. They also mention here that it is encouraged for you to actually create your own test tenant and run security tests against it. So that's exactly what I've done here. I've set up my own Microsoft Azure tenant, and I'm going to be running all of my attacks against my own tenant. So one of the most important tools and documentation sets that you're going to need to get familiar with is from AAD internals. So this is created from Dr. Nestori Sinema, and he works as a principal identity security researcher at Microsoft. So that just tells you the amount of knowledge that went into making this tool. And this chart here is what I'm going to base this entire series of attacking Entra ID off of. So today we're starting at the outsider on the top. And as we can see, the first step is recon. So I'm in my Windows VM here, and I'm going to import module AAD internals. And it'll just take a minute. It should show the banner when it's imported. And there we go. So now let's get some general information about the tenant we're going to be attacking. So we can do invoke AAD int recon as outsider and specify the domain name of our target. So for this, it's redact.com. So at the very least, we can confirm that we're attacking the right tenant that's associated with this domain. And we see that the brand here is the Redact Paper Company. And we also get the tenant ID, which is going to be used in every subsequent API call that we make. The region is North America. Desktop SSO is disabled right now. And this will affect the different mechanisms that the module uses for checking if users are valid or not. And we see that, so there's DNS records pointing to Microsoft. There's mail records pointed towards Outlook, and SPF and DMARC records are present. The type of tenant is managed, meaning that all of the hashes and associated authentication information is stored in the cloud and not in some sort of hybrid environment or completely on-premise. The next thing we can check is if any other domains are associated with the same tenant. So we can do get AAD int tenant domains and specify the domain again. And in this case, there's only the one domain, but if there are multiple that are returned and they're within scope, then that's another domain that you could add to your user enumeration steps and potential password spraying. Now, assuming that we know at least one user that would be at this company, we can try to gain some context about what their email address format would be. So in this case, I just created a file called scott.txt, which holds a couple different email address formats for the user Michael Scott, who we know is the CEO of the Redact Paper Company. So we're going to pipe this into invoke AAD int user enumeration as outsider. And we can see that one of these is a hit. So it's with high likelihood that this is the email address format for the entire company. And as we learn more users through different techniques, which I probably won't get into in this video, but there's a lot of good videos for finding users through LinkedIn to username or dehashed or other tools like Hunter.io online. And we're going to shape our user lists to match this newly discovered email address format. So for this example, I have a file that represents users that we've found through a number of different ways, and we included their name matching this newly discovered email address format. So now we can go through and check all of these accounts to see if they're valid in the same way that Michael's account was valid. So we see some results coming through now. And we get some really good information here that there are only 3 that aren't valid accounts. So A. Bernard, J. Halpert, and P. Beasley. So we can take those out of our file for our user list and then move on to the next step, which would be some generic password spraying. So I'm back in Kali here, and I brought the list of user accounts that were valid. And I also created a password list where one of the passwords is valid for one of the accounts, just to demonstrate the tool. And we're going to be using Trevor Spray, which is a great tool, and it's very customizable to tune it to the account lockout policy that's in place for the organization. So in this case, I'm going to hit enter with these users and passwords. And it immediately starts trying the first password against all the different users. You'll normally get maybe a few password attempts for each user before going into the territory where you could start causing account lockouts. And with an organization where maybe you're testing 300 users, that's a pretty high success rate for some pretty common passwords. So we see that we got a success for the d.philbin@redact.com. And the good thing about Trevor Spray is that it immediately tries some very common MFA bypass techniques. And it also says that we have some successes for MFA bypass, for example, with Exchange Online PowerShell. So that was really quick just because the example used only a few passwords in the list, but you can picture that running for quite a bit of time, and you're going to want to check other things while that's running. So 2 things we can do is try to use a dictionary attack to find some storage accounts in Azure, and also use a tool like TruffleHog to find GitHub secrets if there's a repo associated with the company. So I'm back in my Windows VM here, and I have Microburst loaded, and I can use this to run enumerate Azure blobs and give it the base of our domain. And it's going to take its own list of different permutations that can be added to this domain in an attempt to find storage accounts that exist. So I hit enter here, and it immediately finds redact internal. And then within that, it then checks for different storage containers, and I've named one internal, and it found that as well. So we can list out publicly available files here because we're able to find the names of the account and containers. So I can go into Edge here and attempt to download this file. And when I open it with Notepad, you can see that we get this employee directory. And finally, for GitHub secrets, I'm going to be running TruffleHog. So if you were running this against a real company, you'd probably point this tool at its online GitHub repos. But for this, I'm just running it against a repo that's on my local file system. So I'm going to run TruffleHog file system and point it at the current directory, which is the repo, and let it run. And pretty quickly, it detects that I have 2 potential Azure credentials stored in this repo. So what we actually do with these credentials, I'll probably cover in the next video where we go into what to do after you get a foothold. But for this video, that's good enough. We have credentials and we don't know what to do with them yet. The last major area to cover here is phishing, of course, and AAD internals has its own phishing functionality built into it. So as long as you specify a recipient, a subject, a sender, and an SMTP server that you can send emails from, they're going to craft this nice looking phishing email that gives them a custom link to navigate to and the code to enter once they get there. And if they do click on this link and enter this code, then it will present you with their authentication token that essentially gives you access to their full Entra ID account. Of course, this message here in their example is clearly telling them that it's a phishing email, but when you scroll down here, it shows that you can put any message you want as long as you have those 2 placeholders for the sign-in URL and the device code that it generates. Now, of course, this AAD internals phishing command is just a one-liner that crafts a phishing email for us. But if you're going to do some more advanced phishing attacks, you're probably going to want to set up something like Evil Jinx or evil Gen X, depending on your pronunciation of choice. And this has some more advanced capabilities, such as phishing detection, evasion, obfuscation, website spoofing, persistent data storage, all that good stuff. So that's it for this video. Nothing really groundbreaking here, but it sets us up well for the next video, where we'll go into what to do once you actually get a foothold into the Entra ID environment.